Welcome back, guys. This is Ashwin here. In this video we are going to explore about sampling techniques. So we already seen some of the sampling techniques before for handling imbalance class data. You can check those videos on the top right corner of this video. So now we are going to see two more sampling techniques which is crucial for working on a full-fledged project. So first let's load some data set for doing the experiment. So import pandas as pd. We will load the data frame pd.read csv. I have the data in data folder. You can also download the data set. So this is the data set I'm going to use. This is a wine quality data set. All these are like input attributes and this is a target attribute, but for this video we don't need that actually. So let's see the length of the data. We have around 6,497 data, but in any other data set it can be 10,000, 1 lakh or million samples. So you cannot load all the data at once and do data exploration or do pre-processing and other techniques, because all these techniques will take some time. So in order to avoid that, we will just take a random sample of the data set. So that is our first technique, random sample. So for this, I'll just say sample df equals df dot sample n equals number of samples you needed. For this, I'll just specify 500 and say replace equals false. This replace parameter is crucial. We are just telling that we don't want any duplicates in the sampled data frame. So let's display the sample data set. Now you can just see it just took a random sample of the data set. We can also check the size. Sample df. See, we just took 500 samples without duplicates from 6,497. So that's how random sample works. You can just change the number if you want. Let's say if you want more data, even if you want some duplicates, means let's change it to maybe 10,000. For this, I'll just create a new cell. This is without duplicates. I'll just copy this. This will be with duplicates, creates more samples. Let's say you have only 6,497, but you need around 10,000 samples for some experiment. So let's say 10,000. If we just run the cell, it will show you some error, because you said replace equal to false, because you need the data without duplicates. Now you can see we cannot do that. If you say replace equals true, it will also allows duplicates. We can get 10,000 samples out of it. So length of sample df. Now you can see we got 10,000 samples. But this scenario is very rare, but you can always use it for like handling imbalance class. If you want to replicate same samples, means you can use this technique. But most of the cases for experimenting with different modules, you usually take a subsample of the data set. So this is efficient method. As you can see, the indexes are random. It's not in an orderly fashion. If you want to avoid that, you can just have reset index drop equals true. Let's run this. Now you can see it starts from 0. So this is much better compared to this random numbers. While doing some iteration, this will cause some errors. That's why it's better to do this. Let's copy the same here as well. Run this. Now this is about random sample. The next sampling technique will be stratified sampling. stratified sampling. So this kind of sampling is very helpful if you want to get a uniform train data and test data. Useful to get uniform train and test data. Let's use the same data set as above. So I'll just copy this, paste it here, run this. Now let's explore the distribution of this data set. As I mentioned, this is the output label quality. Let's import Seaborn for this for visualization. SNS dot count plot of x equals quality and data is data frame. We'll just load this module at the top. Now let's run this one. Now you can see the distribution. We have like 3, 4, 5, 6, 7, 8, 9, and this is the distribution. This is for the original data set. When you are doing a train test split using scikit-learn, it might not get a uniform test data. Let's experiment that as well. Let's import the module from scikit-learn dot model selection, import train test split. Okay, now xtrain xtest ytrain ytest equals train test split of, I have to pass the x variable. I can split it here. X equals df dot drop. Columns will be quality, because this is the input attributes we are just dropping, and for output attribute we will just take the quality. Now let's pass this here, x, y, test size. I'll just say 30% test data. Random state is 42. Let's run this. Now let's check the distribution of test data. So SNS dot count plot of x equals y test. Now you can see that 9 class is missing in the test distribution, but in train it would be there, but in the test data this is not like a uniform distribution. You can see it represents other class samples in a uniform manner, more or like, but it completely missed one output label itself. So this sometimes cause some issues while doing training and testing and evaluating the performance. So it's better to have a uniform test data for doing the validation. In order to do that, we can use the same snippet, stratified samples. There is one more parameter called stratify. Here you just need to pass the target variable, that is y. If you do this, now let's check the distribution. Now you can see it resembles the actual original data. It has class 9, and this also has class 9. So it uniformly splitted the train and test samples. So this is much more helpful, and most of the times you might miss this parameter, but this is crucial for doing training and validation of any data set. So make sure to keep this in mind, and even if you want to split the data using some other variables, means you just need to change the target variables and pass the same target here. Apart from quality, if you have other categories and you want to split the data set uniformly, means you can do that. So that's pretty much it, guys. These are the two main sampling techniques that I wanted to share. As I mentioned, other than this, I already covered another sampling techniques like random oversampling, undersampling, smote, etc. in one of my previous video. You can check the link in the description, or you can click on the right top corner of this video. And that's pretty much it, guys. If you have any queries, please leave a comment below. Thanks for watching, and see you guys in the next video.